So all of you keep heading. The next chapter we are going to study is motion in a plane. Chapter number 3. So this is the chapter. Basically, we people will divide into two parts. One is first half of the chapter will discuss about vectors and types of vectors, addition, subtraction, multiplication, division, these all the things. And the second half of the chapter we are going to discuss projectile motion. Is it? Am I audible? Please respond, all of you.
Yes, sir.
Yeah. So that is what. So in our
Yes, sir.
today's class, we are going to discuss scalar and vector quantities, and as well as types of vectors, and as well as angle between two vectors. So let us discuss what is first scalar and vector quantities. So we all know from class 8 we are studying. So scalar and vector quantity. So if you have noticed it here, first of all, so we know that so many physical quantities we are discussing, we are learning from even class 4th and class 5th also, like length, mass, weight, distance, displacement, speed, velocity, pressure, density, like that many things you people are learning from the lower classes. Is it correct, all of you? Yes.
Yes, sir.
So now in this,
Yes, sir.
you know that based upon the certain things, of course, if you take any kind of physical quantity, so already in first chapter I have taught you. So physical quantity is actually combination of two things. One is actually a magnitude into unit. So that is what we used to call as physical quantity. So if I say, for example, let me take what is the scalar quantity. So we have a many physical quantities which we studied, like what I told the examples. So for example, if I take, I have done 10 joules of work, then it means in the sense of, I will say simply the work done by me, which is equals to 10 joules. So if you notice it here, or if I say speed of my car, which is equals to 10 meter per second, or if I say distance covered by me, which is equals to 5 meters. So if you all notice it here, in this all the things, work done by me is 10 joules, speed of my car is 10 meter per second, distance traveled by me is 5 meters. So let me take now same way scalar quantity. You might be understand what is the difference between scalar and vector quantity. I think already most of you are knows already. So now if you see that scalar quantity, so let us discuss now. I'll say I applied the force 10 newtons towards to the east direction. I my velocity of my car is 10 meter per second towards to the west. Displacement shown by me, which is equals to, let me take 50 meters towards to the north. So like that, have you noticed it here? So here and here, what is the difference between scalar quantity and vector quantity? You can find by seeing this one easily. Of course, here also 10 is the U magnitude. Here also 10 is the magnitude. Here also 5 is called as magnitude. And if you notice it here, here also 10 is called as magnitude, and distance velocity is also 10 is magnitude, and 50 meters is also magnitude, and this is the unit. But what is the difference between scalar and vector? You are seeing here, everybody, all of you.
Direction is
Magnitude and as well as direction. So if you have noticed it here, in vector quantities along with the magnitude, you might be notice it. So magnitude we are having, as well as what it is having, as well as it has a direction.
direct.
So specific direction I am specifying. So when I am speaking with the specific direction, then that physical quantity is called as, it's not a scalar quantity I have written here. So what is that quantity we used to called as? Vector
Vector.
quantity. Understand? So vector quantity means you have to remember that. So it has a direction and as well as magnitude. And scalar quantity means it has only what it has. It has only
Magnet.
magnitude. But if it comes to the direction, so what is having, all of you? No direction. So that is what we used to call as what is scalar quantity and as well as what is vector quantity. Can you able to understand everybody? So if it is a scalar quantity means it has only magnitude, and if it is a vector quantity means then it has magnitude as well as it has what, guys? It has a direction. So that is what you
Direct.
have to remember. Now, how to represent this vector? So of course, we are not going to discuss about scalar anything. So whole chapter will runs behind only vector. So representation of vector, all of you remember that. So very, very important. So if you take any kind of vector, so of course, you know that. Suppose if I say speed, so speed means I will represent only v. If I say velocity, you might be knows class 9, those who are old student of me, I used to represent. Velocity means above is to get arrow. Is it right or wrong, all of you? Even last
Yes,
chapter,
sir.
second chapter, we have studied that distance means we'll represent with a yes. But what about the displacement, everybody? Displacement will represent
Above
above
an
with
arrow.
what? Arrow.
Above.
So representation of vector is arrow. So this is what we used to called as representation of vector. So here if you notice it, the length of the vector, whatever you are seeing that, this the length of this tail, this is called as a tail we used to called as. So the tail length is only representing the, actually this is a tail, and arrow, what is arrow called as? Everybody, we used to called as head. Understand
Vector.
everybody? So if you notice that tail is always representing actually length, which is tail of the length which equals to magnitude. So that is what you have to remember. Always tail will represent what? Tail will represent what? All of you?
Magnitude.
Magnitude.
Magnitude. And this
Magnitude.
arrow, all of you remember, this arrow is always representing the, what it will represent? Everybody?
Direction.
It will represent
Direction.
the direction. So that is what you have to remember. So always whenever we are representing the vector, the tail of a vector is always gives you the magnitude, and the arrow will represents the direction. Is it okay, everybody? Yes, please. So now if I have taken, I'll say, so for example, let me take the force. If I say force I have applied is 100 newtons. So means in the sense of, so what is actually, it is acting a certain direction, and this length of this tile, how much I can say? Length of the tile is equals to 100. Understand? So that is what the magnitude. And this arrow is indicating that what? Head. Head is indicating the
Direction.
direction. So I am applying the
Direction.
100 Newton force in this direction. So that is the meaning of that. Now, for example, I'll say velocity. So if you have noticed the velocity, of course, we'll represent it with V only. I'll put arrow. So indicating that, it is indicating that velocity, for example, I'll say 5 meter per second. So towards to what direction it is acting? Towards to the east direction. Understand all of you? So like that, if I say acceleration. So we all know so acceleration is also vector quantity or scalar quantity. Last chapter we studied. So acceleration means what? Rate of change of velocity. Rate of change
Change
of
of
velocity means in the sense of, we all know velocity is a vector quantity. Means in the sense of acceleration is also a what? Vector or scalar quantity. Everybody, it is the, yes, please. Vector quantity. So acceleration, for example, if I say, we all know, so what is the unit of acceleration, everybody? Meter per
meter
second
per
square.
second square.
Meter per
Second
second
square.
square. So I will say acceleration A is equals to, for example, I say 2 meter per second square towards to west, for example. If I say west, means acceleration of a body is 2 meter per second square. In what direction, everybody? In what direction? All of you.
That's right.
It will be west direction. So that is how I used to mention it. Now, if you notice it, for example, so this is how, what is the representation of vector and how we can define a given physical quantity is a scalar or a vector. Is it okay, guys? Any difficulties in this? We all understand, all of you? Yes, please. So that is
Yes,
what.
sir.
So if you notice always tail, for example, if I say magnitude, if I have taken, so if I represent anything like with only magnitude, for example, if I say A is equals to 4 units, I don't know. So this is what we used to call as magnitude. Simply if I say it is a 4 units, so nothing is there. So it is actually a magnitude. If I say mod A, we know that last previous chapter we found from the speed, if you want, sorry, from the velocity, if you want to find the speed, what we have to do? Mr. Rudreswar, we have done it. From the velocity, if you want to find the
Root
speed,
over.
what we have to do? So we all know that magnitude of velocity. Yes, magnitude of velocity we used to call it as what? Everybody. We used to call it as speed. Yes or no? So we have done that mod. Is it yes or no? Rudreshwar, do you remember the root of? We say x square plus y square like that to find the speed.
Yes,
Is it
sir.
right or wrong? Pradosh?
Yes, sir.
Yes. So if I
Sir.
say mod A, suppose if I say magnitude is 4 units means actually it is actually this is also indicating if I do mod or else if I make mod of this A, which will give you actually always what it will gives you, which will gives you magnitude. Understand everybody? So I will say it is how much 4 units. For example, if the same thing if I represent like this, then it is a what actually I'm representing arrow. So indicating what it is. It's a magnitude or it's a vector
Vector quantity.
vector. So I will say A is
Vector.
equals to 4 units towards to north. For example, if I say, then A is also, if I say 4 units towards to the what, guys? Towards to the north. So this is
Not.
the meaning of vector and this is the meaning of magnitude. So if you take the any kind of vector quantity, it is a product of, if of course it has magnitude as well as direction. And if it is a scalar quantity, it has only what, guys? It has only magnitude. No direction is present for scalar quantity. Is there any doubt in this? Please kindly let me know. I will understand. Yes, please. Everybody?
Yes, sir.
That is what. So
Yes,
this
sir.
is what about it. So vector representation. Always remember the tail is actually the magnitude and the arrow is actually is the what? Direction. That is what head we can say. So tail always represent the magnitude and head is always represents the direction. So that
That.
is why arrow is the representation of vector. Okay, so this is what about what is vector quantity or scalar quantity. Now we are going to study types of vectors. All of you keep ready. Types of vectors. So let's start now. Everybody clear? Ishali, understood?
Yes, sir.
Okay. So now, right, types of vectors. So if you have taken, we are having many types of vectors. If you see in our, like even of course, class 9th also you might be get, but not that much in detail. But now you can see we are having many types of vectors. So let us discuss the first type of vector. If you have noticed it, equal vector. What is that? Equal vector. Understand? So means in the sense of if any kind of two given vectors magnitude is same and as well as direction is also same. So let me take one vector is A and another vector is B. So if both magnitude, understand everybody, so magnitude is same and as well as another thing is what, magnitude is same as well as
Direction, sir.
one. So
That.
direction is also same, then that vectors we used to call as what vectors we used to say, we used to call it
Equal vector.
as equal vectors. Understand everybody? Clear? Any doubt in this?
Yes.
Next, equal opposite. What is the equal opposite? Unequal vectors. Okay, so let us discuss what is the meaning of unequal vector. So I have given one is vector A and another one is vector B. See, I am putting above line that is indicating vector. So if I have taken magnitude is different and direction is different, or magnitude is same but direction is different, or direction is same, magnitude is different. Anything is different, then what we used to call? They are called as what? Everybody.
Unequal vector.
Unlike vectors. Understand, brothers? Unequal vectors. What do you mean by unequal vectors? If a magnitude is maybe magnitude is same, but what is not same? Direction is not same. Understand? Or direction is same, or magnitude is not same. Or magnitude is different, and as well as direction also what? Direction also different.
Different.
Then that is called as what vectors we used to say? Everybody. We used to call as
Unequal vector.
unequal vectors. Any doubt in this? This was clear? Next, parallel vectors. Third type of vectors is parallel vector. Now, if I take here any kind of vectors, if they are having the same direction, understanding magnitude may be equal or may not equal. Understand, Laksha? Sai Karthik? So magnitude may
Yes.
equal or may not equal. Then also we used to call as if they are having the same direction Then if you notice it, same direction, then they are called as what we used to call parallel vectors. Clear everybody? Parallel vectors. Now can you tell me what is the angle if there are two vectors are parallel? Anybody? Theta is equals to what is the angle between them?
Theta.
Yes, please. Theta is equals to how much? If there are two vectors are parallel, what is the angle between them? Everybody, angle between them
0
is
degree.
0 degree. That is what you have to remember it. Next, anti-parallel vector. So you all people knows anti-parallel. So what is anti-parallel means? Everybody? Yes, please. Both are same direction or different direction? Both are different
Different
direction.
direction.
So irrespective of their magnitudes. So magnitudes is not matters. So irrespective of their understanding. So the same, maybe magnitude is same or maybe different, doesn't matter. If any two vectors having the different directions, okay, everybody clear? So that is what we used to called as, what we used to say, all of you,
Anti-parallel.
anti-parallel direction. For example, if both are same line and opposite, then what is the angle between them? Can you tell me? Yes, please. What is the angle between them? Theta is equals to
180.
180. Understand? That is what you have to remember. Clear? Any doubt? Anybody? All of you? Okay. Next, fifth type of vectors, collinear vectors. Collinear vectors means if two vectors are in a same line and same direction. All of you remember that? They must be in a same line and as well as same direction. And they is to called as collinear vectors. Next one, coplanar vectors. Coplanar. So mathematics, you all people knows. Coplanar means how many? Any two vectors, if you have taken any two vectors, not one. If you have taken any two vectors, if you are having the same plane, so always if you notice it, any two vectors are always coplanar. So not only two, three vectors are may or may not be coplanar, but always two vectors always what guys? Two vectors always they are the coplanar. But if you have taken the three vectors maybe or may not be. Of course, we'll study so many examples. May not be coplanar. But if you have taken always two vectors, if you have taken any two vectors, always they are what? Rudreshwar? Coplanar.
Coplanar.
Okay? So that is what you have to remember. Next, concurrent vector. Concurrent vector. So if you have taken the concurrent vector. So if we see acting at same point, that is what we used to call as, what vectors we used to say? Acting at the same point. We used to say
Concurrent vector.
concurrent vector. Acting at same point. We used to call as concurrent vector. For example, this is one vector, this is the point, this is the another vector, and this is the another vector. So let me take this is F1 and this is F2 and this is F3. So all are acting from the what point? Everybody? All three vectors are acting from the same point. Is it yes or no? Everybody?
Yes, sir.
Then this is called as, what we used to call, all of you? Concurrent
Concurrent
vectors. Next, zero vector. Zero vector means in the sense of zero vector means, all of you remember, zero means we used to say like arbitrary. Arbitrary in the sense of like any direction it is passing. Any direction it is passing, or the magnitude of that vector is zero. Understanding? So then we used to call as zero vector. All of you remember, like any kind of thing, if it is passing in any direction, we don't know particular direction, then direction is not mentioned, then or else magnitude is zero, then both the things what we used to call, everybody, it is called as zero vector. If direction is not specified or it is magnitude of the vector is how much ra? Magnitude of vector is zero, then that is called as zero vector. Next, unit vector. We all knows unit vector means. Can you tell me what do you mean by unit vector? Of course, unit vector is represented like this. So can you tell me what is a unit? Unit means how much? Value is equals to how much, Ra? 1. Understanding? So that is what you have to remember. Means in the sense of magnitude is equals to 1. Then if you see, you can, all of you may remember that whole purpose of unit vector is only direction. That is the important of unit vector. Whole purpose of unit vector is what it will indicate, guys. Everybody, it will indicate the direction alone. Understand? So whose magnitude is always how much? Magnitude is
1.
equals to 1.
1.
This is what we used to call as unit vector. So these all are the types of vectors which we are, of course, we are going to solve so many like these things in our the next coming classes also. So this is what about it. What is the types of vectors? Understand everybody? Is Sai Karthik, Pradosh, Murali, Mani and
Yes,
Samya,
sir.
both of in same meeting? Okay. So this is what about what is the types of vectors. Okay, Pradosh, clear? Next. So we are going to study the
Sir.
next one is, so this is one of the very important one. So that is what we used to call as parallel shift. Already when we are solving the boat and river problems and rain and umbrella problems, we remember that parallel shift for finding the triangle angles, we have been done it. Is it right or wrong? All of
Yes,
you?
sir.
Yes,
Yeah.
sir.
So you need to, whenever you are finding this next vector addition and subtraction and all, you might be remember. Okay. So always this parallel shift is very important one. So let us discuss what is this parallel shift and how to make the parallel shift of a vector. For example, if I say this is the vector, so can you tell me what is a parallel shift means? What it will comes, where it will comes parallel shift. So parallel shift will come in the exactly parallel to this. So this is what the meaning of parallel shift. Understand everybody? Brothers. So if I extend this one like this and this one like this, so that is the meaning of what? What is to call? All of you. Parallel shift. Understand? So for example, one vector is like this. So what is the meaning of parallel shift? If I extend in parallel direction and if I draw anywhere the same like this, so that is the meaning of parallel shift. Is it right or wrong? Everybody? All of you.
Yes.
So this is the meaning of parallel shift. So for example, I will give you force is 10 newtons this direction. Can you tell me what is a parallel shift? All of you. What is a parallel shift? Anybody? Parallel shift means for this one like this. Understand Rudreswa? Pradosh? Clear? Okay, Ra? If it is a
Yes, sir.
horizontal, for example, if I say this is horizontal, 100 newtons. So then what is the parallel shift of this one? So if I extend like this, that is only the parallel shift. So this is what is the meaning of parallel shift. Of course, we are having importance of parallel shift. Why means whenever we are finding the addition or like angle between any two vectors. So then by extending the parallel shift only, we people can find it. So shall we start now, everybody? All of you?
Yes,
Yes.
sir.
So that is the concept we are going to study is angle between two vectors. Angle between two vectors. So all of you remember without this concept we cannot. So observe very carefully and if you have any doubt you can ask me. Now, so I will take this is the one vector. All of you observe and this is the another vector. Now can you tell me first vector what is the head and what is the tail? All of you see that you have to see for every vector head and tail. That is very important. So first vector this is what actually everybody. So let me take this is a head and this is a what actually tail. And second vector, this is the tail and this is the what actually? All of you.
It-
Head. So if the two vectors are perpendicular to each other, so can you tell me what is the angle? Everybody. So the angle is
90
equals to
degrees.
how much? 90
90.
degrees. Clear? So just I'm giving you examples. Clear? So if you notice it here, a tail to tail or head to head, if both are attaching, so always if you know, for example, I'll say this is the head and this is the head. Then also what is the angle between them here? All of you? Yes,
90.
please.
90 degrees.
90 degrees. Understanding?
90.
So tail to tail or head to head, always angle is equal to how much? Everybody, 90. Understand? So now, if I will draw like this, all of you observe. So this is the one vector and this is the another vector. So can you tell me what is the angle between expected angle between them? Any guess? So this is, let me take this is a vector and this is a b vector. So now what is the expected angle? So for example, if this is perpendicular, then what is the angle, Rudreshwar? Yes, please. What is the angle? If it is perpendicular, what is the angle, guys?
90 degree.
90 degrees.
90
Sir,
degrees.
no. Now it is more than 90. So let me take that angle between them is how much it is? All of you.
Fusion.
150 degree. Understand? So now, for example, if I draw like this. So this is one vector and this is the another vector. You can see if it is perpendicular, angle is 90. So now let me take this angle between them. So this is one vector A and this is another vector B. So I will consider as angle between the two vectors. What is that? It is maybe a 60 degrees. Understand everybody?
Acute angle.
Yeah, acute angle. So next, if you have taken one more example, let me take this is a B and this is a and this is a D. So now if you have noticed it, for example, if I take this is one vector and this is the another vector. So now, so maybe the expected angle, if you have noticed it, so the angle maybe if it is take this is the A vector and this is the B vector. So the angle between the two vectors is how much, guys? Angle between the two vectors is all of you. So I will draw this is a
100.
straight line so that you might be clear. So this is what I will draw. So now what is the expected angle between them? Maybe it is a, how much it is? 150 degrees. So like this, whenever you are seeing angle between the two vectors, just I'm giving the examples. Now we are getting the importance of parallel shift and all. So this is what like how when the two vectors are joining, you might be see that here tail and tail is attaching, here head and head is attaching. Here what is attaching? Have you noticed it? One head and one tail. Clear? And here both head and head is attaching. And again here one tail and another one is what? Everybody. One head is attaching. Is it clear, everybody? So now let us take for example, I will give you one thing that is what vector A and another vector is B. So this is what I used to say vector B. So the angle between them is how much it is, everybody? 120. I'm taking as. Now, if I extend the parallel shift of B, can you tell me how to extend the parallel shift of B? Anybody? What direction it will come? Just now we studied. Parallel shift means how it will come, Ra? It is a horizontal, so that it will come how? It is also called as parallel shift. Is it right or wrong, everybody? Yes, please.
sir.
Then, if this angle is 120, can you tell me what is the angle between this one, parallel shift and A? Everybody, total angle means we know that. Total angle is means how much it is, which is
180.
equals to 180. Now, if this is 120 means here how much it will come?
60.
60.
60 degrees. Understanding? That is what you have to remember. So always you remember. So whenever all of you observe head to head, if it is making, or if you notice the tail to tail, all of you remember the angle between. If suppose like this is the head and this is also head, then the angle between them, which is equals how much? Everybody, head to head. How much is the angle? Or here, what is that? Tail to tail. So tail to tail, how much the angle cut? We got it. How much it is? Yes, please. 60 degrees. Understand?
60
They will ask
degree.
you, they will ask you what is the angle between now head to head. Can you tell me what is the parallel shift of B? Here I can draw. So this is the parallel shift of B. Is it okay, Rudreshwar? Can you tell me?
Yes, sir.
What is the angle here? Can you tell me? We know that in intersecting lines. So if here is the 60 degrees, then here also how
They
much?
are also 60 only, sir.
Yeah. So that is what you have to remember. So the for that purpose only, we people are making this one. Understand parallel shift means? Understood or not, everybody? Clear?
Yes.
Yeah. Next,
Yes.
for example. So can you tell me what is the, we already found it. This is, so head to head is 60 degrees. Okay. And if you notice it here, tail to tail, sorry, tail to this tail, of course. This is the tail of this parallel shift and this is the tail of this vector A. So here also how much is the angle? Everybody. Angle is how much? Yes, please.
60 degree.
60 degrees. Okay. So if I taken here, so like whenever I can draw like this, all of you remember it is acute angle. So always if this is the vector B and this is the vector A, so then what is the angle between them? Acute angle means definitely it will be how much? They will give you the number only, which is equals to how much, guys? Which is equals to 60 degrees. Now, my question to you, the next question. So let me take all of you. So I will give you the vectors like this. I want to find the angle between the parallel shift of B and A. So let me see how I'll find. So angle is equals to 150. What is the angle, everybody? All of you? Angle is equal to how much? 150 degrees. Now, I want what is the angle between this is what, and another one is parallel shift. So parallel shift means exactly will come here. So can you tell me what is the angle between them? I want to know. 0. What is the angle? Anybody? Parallel shift of this one. Parallel shift of B, Pradosh. How much angle? Please concentrate here, Ishali. Rudreshwar. So extend this one in a parallel shift.
30.
If I extend here, so we all knows what is the angle here.
30.
Yes, please. So this is 150 and remaining is how much, guys? This is theta is equal to how much?
30 degree.
30 degrees. If this is the 30 means, I'll extend the parallel shift. So here the parallel shift will come. So that is what here I am drawing. Then angle between the head to head also how much it will be? That is
30
also how much? 30 degrees. That is what you have to remember. Clear? Understood? Ara? Yes, please. All of you.
Sir. Yes, sir.
So now let us find, I will give you some vectors. So you all need to find what is the angle between them. So first thing, let me draw the vectors, all of you observe. So this is a vector A, all of you observe very carefully, and vector C, let me take away, this is vector D, and this is the vector C, okay? And if I imagine this all are in the same plane, so all of you observe, and this is the vector B. Clear, everybody? Now angle between this and this, which is equals to 60 degrees, angle between this and this, which is equals to 30 degrees. Clear, everybody? Now your duty is you have to find angle between A and B, okay? Next B and C, next A and C, and next A and D. So this is what our target. So let us find, everybody. So how to find it? You all need to tell me one by one angle. So first, you tell me tail to tail. You have to say that. What you have to say, everybody? Tail to tail, or you have to say head to head. So I'm asking now, tail to tail. What is the angle? You should say it. So can anybody first? So if you all observe here, so we all knows that theta varies from, if it is a parallel axis, we all knows that theta varies from where to where. It is varies from 0 to how much it
180.
is? 180. So whatever it is. So that is what you should remember that. So tail to tail, always remember. So theta varies from 0 to less than or is equals to 180. It may be equals to 180. So that is what you have to remember it. So now observe very carefully. If I observe particularly these two things, understand? So let me take for example, angle between the two vectors is 60 degrees. So then what is the outer angle? Anybody? What is the outer angle? You can check it. Remind
300.
exterior angle. Exterior angle is how much, Ra? All of you?
300.
300. Understanding?
300.
300 degrees. That is what you have to remember. So always remember, if I have taken a plane, always angle is varies from 0 to 180 degrees. If I know the interior angle, of course, this here to here angle is 60. So means the remaining angle, it will become how much, guys? It will become how much? Yes, please. 180 degrees. Understanding? So now if you have been
180.
yeah, for example, so tell me, if here it is 60 degrees means, then what is the angle here? Everybody find it. How much is the angle? All of you respond.
90 degree.
90 degrees.
90.
Then here to here is how much, Laksha? Here also it will become how much?
90.
90 degrees.
90 degrees.
Understand, everybody? So if here to here 90 means, next you check it. How much we have? How much we have? All of you. We are having 30 degrees. Understanding? If this is the 30 means, then this is the 60. 60 plus the 30, 90 over. Then what is the angle between them?
90 degrees.
Everybody. Angle between them
90
is how
degrees.
much? 90 degrees. That is what you have to remember. Now, what is the angle between A and B? A is coming like this and B is going like this. So what is the angle
90
between
degrees.
them? All of you.
90.
90 degrees. Next,
degrees.
B and C. What is the angle between B and C? Everybody check it.
120.
What is the angle between B and C? Everybody. 120
120
degrees.
degree.
Next, what is the angle between A and C? Rudresha?
150
A and
degree.
C. Yes, please. A and
150
C.
degree.
See, A is like this and C is like this. So observe very carefully. A is like this and C is like this. But I asked you a question. Say from where to where? You have to say from
Sir, tail to tail.
tail to tail. So if you notice it, so this is the head and this is the head. So I want to say tail to tail. So imagine that like this it is. This is A and this is C. Is it correct, Rudresha? Clear? Yes,
30
please.
degrees.
Yeah. Then what is the angle to tail to tail? How much, guys?
30 degrees.
30 degrees. Understanding? So everywhere you should say 30 degrees, like the tail to tail. So B to C, what is the tail to tail? B is like this and C is like this. So what is the tail to tail angle? We know that this is 90 and this is 30. How much it is? All of you, which is equals
120.
to 120. Now A to B also we have to say tail to tail, Rudreshwar. What is the angle? A to B tail to tail. So this is A
90 degrees.
and this is B. What is the Pradosh? A to B tail to tail. All of you, 90 degrees. Yes or no? Everybody. Next,
Yes,
Yes,
sir.
sir.
they're asking A to C over. Now A to D we have to find it. So observe very carefully. Now D is like this. Is it right or wrong? D is like this and A is like this. Sorry, A is like this and D is like this. So can you tell me if this angle is 60 degrees means, then what is the angle, remaining angle? Yes, please. All of you. What is the remaining angle? How much?
120 degrees.
300 degrees. Or else, sir, this is not clear. So let me draw. I will bring this D and I will put here. Is it correct, Rudreshwar? Right or wrong? Yes, please. All of you. So this is the A and I'll put the D like this. Is it okay? Aksha?
Yes, sir.
And they are saying that this is what is the A actually, if I imagine. So this angle is how much they are mentioning? How much they are mentioning here, guys? Please respond. 60 degrees. Means in the sense of they are asking tail to tail. So what is the remaining angle? Tail to tail. Everybody.
120 degrees.
Yes, please. How much, guys? All of you. Tail to tail, how much
120
angle?
degrees.
120 degrees. That is what you have to remember. Is it okay? Everybody understood?
Yes, sir.
Yes.
Yes.
So that is what you
Yes,
have
sir.
to remember. So tail to tail, how to find the angle? You understood or not? Everybody clear? So we have to join the tails. Okay, that's all. Nothing is there. So now, for example, they'll ask you tail to tail DC. What is the angle? Tail to tail. What is the angle DC?
90.
90. What is the angle between B to D? Tail to tail. B to D. What is the tail to tail angle?
150.
90 plus 60. How much? 90
150.
plus 60. All of you. So this is the B and this is the D. So here is the angle is 90 degrees and here is the angle is 60 degrees. So total what is the angle? All of you.
150.
150 degrees.
One.
Understand, Ma? Laksha? Clear?
Yeah.
Yes. So this is what we used to call how to find the angle between the two things. Either they will ask you in exam. How to ask? They'll ask you find the angle between. Find angle between head to head, or they will ask you what? Tail to tail.
Tail to tail.
So that is what. So tail to tail, we